Hello, everyone. This is Majid here. I'm here with Rasa and Kirtana, and we're going to talk about bounty number 5 on Memanto um, GitHub project. Okay, I'll just share my screen and start talking about Memento. For those of audience who might not know, Memento is an open source project. It is a memory for AI agents. It is designed as an agent itself, and its job is to manage the memory for other agents. It's a specialized agent. It works with a specialized backend system called Murche, which is a custom built, custom designed semantic search engine and database. So today we're talking about one of the bounty programs. So we had several bounty programs so far. This one is bounty number 5, and we put it out there as Memento Bug and Exploit Challenge. It's been going for about more than a month right now, and it has been drawing a ton of contribution from the community and a lot of work from the team to review those PRs. The goal and objective was to find bugs and security issues within Memento and offer solutions for them. So this would, even though we're going to close this particular issue today and give the prize, cash prize to the winner, we're going to open again this kind of challenges for improving the security and um, quality of Memento. So this should be ongoing process. Now I stop here and I pass it to Rasa to tell us more about the numbers, the engagement so far, and then we would uh, have we will dive into the some of the top submissions, and there Kirtana would also explain some of the submissions, and then we will pick the winner, and live on the screen I would release the cash prize for them. Okay, so that's the agenda for today. So I stop sharing and allow Rasa to take over.
Yeah. So this is pretty much up the bounties we've done up until now. This is probably by far the most one that's gotten the most attention, the most attraction, the most amount of PRs. So basically, we've calculated it all, or I've calculated it. We've gotten about 400 PRs. So like that's
Oh,
400 PRs. We've like excluded the spammers who have like added even more PRs. And among the legitimate one, we've gone like 400 PRs, 200 unique users, and it's resulted in 70 more unique contributors.
mhm.
And of the ones that we've reviewed so far, because there's so many, we haven't really been able to review like every single one of them. About 140 of them
Rasa,
are
would you share your
yeah,
screen?
yeah, yeah.
Yeah,
Okay.
and show us the numbers on the screen.
Yeah. So yeah, we have been keeping track of pretty much all of our progress and trying to divvy up the work between all of us as well. It's been like such a major effort trying to group the PRs into different things so we don't run
Uh,
into conflicts with each other and then like conflicting changes and then merge conflicts.
yeah,
So
kudos to you guys, like reviewing 400 PRs, even though we have the Code Rabbit, and Code Rabbit helps a little bit with the pre-screening the PRs and giving some suggestions, but still there's a lot of work to go through 400 PR, right?
yeah, so we have been pretty much working throughout the month consistently on this.
Yeah.
And I mean, mainly the reason that we kind of have this bounty ongoing, or there, because like on the surface level, Memento's like working fine and everything, the UI is good, but there's a certain level of like battle heartedness that memanto would be able to get by having like a significant amount of users, and then those users would be able to, find bugs, report them, and
Mhm.
then we'd like fix them. But now we've sort of like gone through the process a little faster. So like we incite the developer community to actually go in and test memanto and like, okay, we want you to try and break this thing so we can fix it, so that
Mhm.
we battle harden it before like a significant users actually get into using it. And a lot of the changes we've seen, it's hard to summarize the changes of 400 or so PRs because they're all like doing different things. Some of them are working on like integration, some of them are fixing like documentation, some are working on like the memory, some are working on security, some are working on like the file configuration, some other
Mhm.
bugs. And we've been trying to work on all of these and also try to isolate PRs that have stood out. So we in the bounty, the way we do have to determine a winner, and we have to the way we sort of are deciding how we want to determine the winner, we're putting probably the most weight onto how critical the bug is. Like
Mhm.
the bug actually breaking something. Some examples found are in one of our update memory endpoints that we would have in order to update a memory, we would like delete the memory and put in a new one. But then if like the server was down, then it would delete the memory, but then updating the new one wouldn't work. And so we'd have like permanent data loss. So that's like one of the examples of some of the big bugs that were sort of exposed by this bounty. And
Mhm.
there's a lot more of those. And those are the ones we kind of want to bring attention to. And I will be going into, I've made sort of like a top 10 ish.
Yeah.
It's not like a strict top 10, but these are like 10 PRs. The top PRs are more significant, but these are like a list of PRs that I found contributed and like took on like very significant bugs or like dealt with like memory loss or like data injection or like major security issues. So we'll be going from rank 1 to 10. We'll be discussing what exactly these PRs fixed and how exactly it makes Memento better and like more security hardened. So
Yeah. So just before going forward, I just want to add a note here. So all those 200 people who contributed, we're really grateful for having you and for your contribution. Those 70 who became real contributors to Memento project, we appreciate you and we want you to be a part of the community. Join us on Discord and we're gonna give you more credits on and usage on Murcha platform, which includes access to cloud models and all a lot of models, access to the knowledge management system, semantic search, and you can use it for all the projects you're doing and for other projects and you can have and more Memanto credit. Like Memanto is free itself, but you can use the credit towards running the memory for your agents. So please connect with us, discuss us, and let us know how we can pay back for your contribution. So this cash prize is just a small uh, uh, payment, but and it can go only to one contributor, but we would not let we want to pay back to everyone who contributed, especially top here. Yeah. So yeah, let's dive deeper into some of the most interesting PRs that stood out for you guys.
Okay.
yeah.
So for our winner, we have PR 1502 by Valence Alignment. And this one basically had a pretty critical bug. And so I guess for some background, Memanto's CLI and local dashboard need to talk to the server constantly. So because there's a built-in shortcut. If a request network connection genuinely comes from your own machine, 127.0.0.1, the server will trust it without requiring a password or API key. And so that seems reasonable. But let's say if you're browsing any website, like an ad or a forum link, it doesn't matter. And then that page has JavaScript that quietly sends a request to localhost. Your browser sends it automatically. The instant the page loads with no click and no warning. From the server's point of view, that request looks identical to you intentionally using your own dashboard. There's no way to distinguish the two from where the connection landed. And so this one was really serious. This bug was really serious. We want to thank the user for finding this one, because Memanto's server also has its CORS policy wide open. So any website is allowed to actually read the response it gets back, not just fire a blind request. So the attack chain was a malicious pages script creates an agent through your local server, activates it, and then the server hands back a real live session token in the response, which the malicious script can read directly. From there, it can use that token to read, write, and even delete the actual memory stored under that agent. And all of this happens with zero indication to the person browsing that anything occurred. The way this person fixed this was to ensure that the server now checks three things from the browser itself: the origin header, the host header, and a newer header called secfetch site, instead of just trusting where the connection physically landed. So origin and secfetch site catch a straightforward malicious website, and the host check specifically catches a sneaker trick called DNS rebinding, where an attacker's domain is set up to resolve to 127.0.0.1, making the connection look local even though it isn't. So we want to give the bounty to this one, Valence Alignment. Thank you so much for finding this bug. This was a really serious one. So congratulations.
So I will be going through the rest of the people. So
Yeah.
I
Let's
won't be
do
going
it quickly.
not much detail.
Yeah.
So number 2, this was actually a recurring contributor, so EJ Speed.
Oh yeah.
So he actually pointed out a few bugs. So one of the bugs that I pointed out was actually done by him in the whole memory update flow, in which we would delete first and then add the new memory after. But like the problem with that is that what if adding the new memory fails and then you just lose the memory entirely? So
Right.
you fix that. There's a few others. Some of these have been tackled on by other PRs because there's a lot of overlap in what people are working on. So another one he worked on, this is more of a MD injection issue where certain line endings would survive the truncation, and then you could sort of inject headings into markdown format and make certain memories appear more important and memento injected when normally that wouldn't be the case. So that's our second place. I'll be going.
That was a very good effort and good catch.
Yeah.
They did great job.
So I'll go through the rest a little more quickly. So
Sure.
the third place, I found there was a PR that pointed out that if you had, because we have a memory parser, it'll check for tags in like the content to like apply metadata to the to Morche. But if you had tags as natural content, it'll like take that and think that's what the metadata is when it actually isn't. And if that was the case, it would ignore all the memories below it and
Wow.
use all that information.
Another very good catch. Thank you. Yeah.
Yeah. Number 4 was more a limitation on the tagging. So like we have character limits for memories. There's like a 10,000 character for limit for memory, a character limit for title, but there weren't any character limits for tags. So like if someone felt like it, they could have like put in 1 million characters for tags and we would have no bounds to check for that. Or instead they could put like 20,000 tags and nothing to stop it. So they noticed that and implemented a bound for that. For 5, there is like in our TypeScript SDK, this is our recent TypeScript SDK, there was an event listener, which we opened up when we created an SDK, but we didn't close it, and then that caused memory leakage. So they fixed that. And then 6, I'll try to go a bit quicker. It's another MD injection thing where information disguised as MDs. So like if you had like hashtags, then it would disguise itself as like memanto instructions when actually it's just disguising itself as content. And then this is 878. This is because multiple people worked on the same issue. This is the memory update issue as well. Number 8, we had an issue with the search as of endpoint where it would incorrectly filter out valid memories. Another issue where tag metadata could leak into the memories. And then the last one, actually, Cortana worked on this, so maybe she can explain this a little bit how it worked.
Yeah, this one was basically the same issue as our top one. It was just on a smaller surface. So like the local dashboards management controls, like restarting the backend or shutting the server down. So it was the same root cause. A malicious website could send requests to your local server just by being open in your browser, and the server couldn't tell that apart from you intentionally using your own dashboard. So it was pretty much the same issue as 1502, just the main difference was severity. This one just lets an attacker disrupt your server, and while that's serious, it's not as serious as like letting an attacker steal your actual data.
Cool. Very good. Yeah. So let's do the actual claim acceptance.